Evening.
Make it a drive with the evening, Lester.
Repeat, sir.
Make it a drive with the evening. Like one come and you just say evening. Jesus.
Say, read my mind.
Same way, so there's a few time to come in, all right?
Okay.
All right. Nesta.
Yes, sir.
All right. Congratulations on completing your EDICO. I am, as always, very proud of you. Um, I'm going to ask that you just do some revision on the topics that I've already covered.
Yes,
And for
sir.
the and for the other two who joined the class and don't say good afternoon, a very pleasant afternoon to you. And I'm going to ask that you go to your EducaSoft now, try and complete your assessments. Nesta has already completed hers. And in the meantime, please just go through what it is that I have been doing because I'm going through the big boys, as I told you. And, there is a continuation to the multivariable function that we started that I'm going to be doing, continuing in class tonight. So just continue working. I'll just wait until a few more come in. Just continue working on the EDICO. Please start it for those of you who have not started. And for those of you who have done the work already, just go through the notes that I posted in the WhatsApp group last time around. And then we'll get started in about 10, 15 minutes. All right?
Sir, I post work in the WhatsApp group, sir.
Yeah, man.
Sir, long time one.
Yeah, what we did with oh goodness, wait name. What we did with the multivariable function, I sent it off.
No, sir.
Hold on, they're not tell me that. Hold on.
Sir, the one that we did last class?
Yeah,
No, sir.
you know, send off.
Sir, sir, I asked you several times and I haven't sent it.
You asked me since week. Calculus two. You asked me since week. I mean, since this week.
Tuesday, sir. A Tuesday this? Monday. I asked Monday.
Hold on, because I know I copied it, so chances are it copied. I never send off to you. Call. Next time, Mister, call me here, cause me. You're right. I
Sir,
don't
you
see.
even replied and said you will do that.
Yeah, because I know I worked on it. I know I
O-
worked on it, but maybe what I did was to just copy it and not send it off.
Okay.
So I know. Oh, Father friend. Mm, 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 mm. I never go to the other computer. I know I did it, because when they said it to me, I copied it, but clearly I copied it and it's still in my send something. Clearly I never sent it off. All right. I'd have to go boot up the other computer. I'll come in. All right. System is up now. Let me look into my drafts. Because I know. See there? That is it. I know I did it, but it just wasn't sent. Well, it was done, but missing it was done. Oh, come on. It was done from the 16th. Wow. 11:43 on the 16th. Alrighty then. Oh, come on. Nesta, are you seeing the recording, Nesta?
Going to look, sir.
Yeah, because I know, I don't know, I got distracted by this wasn't sent because I actually did it from the 16th at 11:43 p.m. Converted the file, but I just didn't send it.
Sir, which recording?
Last week Friday.
No?
Well, I don't know what is happening because I know I sent both. I sent the Friday one off and I sent the Saturday one off on Saturday. So something
Oh,
is not happening because both of them I know were uploaded.
check one can. Hmm.
All right. The computer with the notes is taking its own little time going through. So let us just let us see if we can do some recap. Let us see if we can do some recap. So what we looked at was some multivariable functions. And the multivariable functions are those functions containing both x and y. What are we going to be doing with those? We're going to be finding the stationary point. The question that we used in calculus 1 was to look at the stationary point of a single variable function. Good evening to you. A single variable function. Now, the single variable function only contains, as it says, single, one. Your multivariable function can contain more than one. But in this case, we are only concerned with the multivariable functions with only two variables. You have multivariable functions with three variables, x, y, and z, and you can have multivariable functions with any amount of variables. It says multiple, so any amount of variables. But the one that we'll be focusing on for Cal 2 would be multivariable functions in two variables. And we'll be utilizing x and y. Sir, the question could come anything else? Yes, ma'am. They can give you alpha and beta. But don't worry about it. The concept will be the same. And as the system is giving me a blank screen now, let me just continue talking. So there are 6 calculations that we must do once we get that multivariable function in order to go about classify the points or seeing where we can maximize our function or the sale of an item. There are 6 calculations that I must do. Can anyone remind me of the 6 calculations that we always do for the multivariable function question? Can anyone remind me?
Sir, I remember. I remember about
F subscript X, F subscript XX, F subscript Y, F subscript YY, F subscript XY, and S subscript YX. Please to try and remember that. Those are the 6 calculations. All right, so I sent the document to the WhatsApp group. Are you seeing it?
Yes, sir.
Yes, sir. Looking through.
All right, cool. So Nesta, what I did, I actually prepared the document, and it was sitting here from the 17th at 11:43 p.m. and I thought it was sent, and it wasn't. So it took a while because the document was there. It took a while for it to open the document, or maybe it's just that my system is very old. But anyhow, I'm now sharing the document um, that I prepared for you. It's just a pity because we did only up to here last time around. And my intention really was to have you go through these, but never mind. I won't. I won't fuss over it. It's my error. All right. So these are the 6 things that you need to calculate. Once we ask to find and classify the critical points, the question may come as simple as that, find and classify the critical points, or you may get an application type question where it tells you a story, and then now you have to go do what you need to do from the story. And we'll look at some of those questions tonight. Yes, my love.
So basically, regardless of the scenario, it's the same process that you like, the same calculation that you do?
Yes, ma'am.
Okay.
Mm-hmm. Yes, ma'am. Regardless of the scenario, this is what we have to do. F subscript x, F subscript xx, F subscript y, F subscript yy, F subscript xy, and F subscript yx. You know what? Let me just tell you again. I don't know how the paper is going to come, but my F subscript x and my F subscript y are known as my first order partial derivatives, which is why I have the FOPD, first order partial derivative. How you know, sir? Look at my subscript. I have only one. I have only one. So this is known as my first order partial derivative. My second order partial derivative, because I have xx and yy, I have 2. So that can be considered as my second order partial derivative. Why this one is called my cross order partial derivative, because I have both x and y in them. You notice here for the second order partial derivative, I just have xx and yy. But my cross order partial derivative, I have xy in one instance and then yx in another instance. So say for example, you get a multiple choice question and the question says, given f of x is equal to 3x squared y plus y cubed minus 3x squared minus 3y squared plus 2. Calculate the cross order partial derivative. Rockstone. But home again with that, not a problem. They want the cross order partial derivative. So what you have to do is to calculate f subscript x, f subscript y. And then from your f subscript x, the first order partial derivatives. Remember, nothing can be done without first doing the first order partial derivatives. So having done the first order partial derivatives, then now you just move to the cross order. So you're going to be using your f subscript x to evaluate f subscript xy. And you're going to use your f subscript y to evaluate f subscript yx. So that's how you go about doing it. So you have to know what to talk about first order partial derivatives, second order partial derivatives, as well as your cross order partial derivatives. Very important. Any questions?
No, sir.
All right. So having done those, we now need to go ahead and find the value of dy by dx. when it's equals to 0. I have to find the value of dy by dx when it's equals to 0. But sir, we don't have a dy by dx. I agree. So my f subscript x is my first derivative. I'm going to set that equals to 0. So therefore, I'm going to let my f subscript x, xy to be equal to 0, and f subscript y of xy to also be equal to 0. To also be equal to 0. All right, so I'm putting those two sets to be equal to 0. Two sets to be equal to 0. All right, so you can have your, first order.
Sorry for speak for cutting off. This is what you did last week, right?
Yeah, man, that's what I
I
did.
didn't get to watch the video. Okay.
Yeah, man, that's what I did. All right. So my my first derivative of x and y, what I did, so yes, utterly, what I'm doing is just a quick recap. So what I did here now was to set my first order partial derivatives to be equal to 0. So you notice I have 6xy minus 6x equals 0. Sorry, my f subscript x of xy is 6x minus 6xy minus 6x. Here, I'm putting it equals to 0. Similarly, my f subscript y is going to be 3x squared plus 3y squared minus 6y. I'm setting that equals to 0. I'm setting that 1 equals to 0. What it is that I'm doing here is looking at my two equations. I recognize that the first equation is a linear equation. Sir, how do you know that it's a linear equation? It's a linear equation because it's a linear equation because the highest power raised in that equation is 1. 6, x raised to the first power, y raised to the first power, minus 6, x raised to the first power. All right? And then the other one is called a quadratic. Why, sir? Because the highest power raised in that one is to the second power. It's raised to the second power. Any question?
So I get the last part, but where I have 6x in bracket y minus 1 equals 0. What is that saying?
All right, so give me half a second. You're ahead of me.
Oh, okay, so
All right, so we need to solve both equations simultaneously. How do we do this? We are going to look at the first equation, and when in the first equation, we recognize that 6x is common to the two terms. One we have 6xy, the other one we have 6x alone. So what we're doing there is to factor out the 6x. So that's what I'm doing here, Daniel. I'm factoring out the 6x. And when I factor out the 6x, what is going to be left here? Look at what I color coded. I'm going to have just the y that is left. And when I factor out 6x from 6x, I'm going to have 1 left. So that's why I end up with a minus 1 here equals to 0. Can you see that?
yes, sir.
So either 6x here is equal to 0, or y minus 1 equals 0. So I have two scenarios here. Either 6x is equal to 0, and if 6x is equal to 0, that implies that x is equal to 0. It implies that x is equal to 0. And if y minus 1 is equal to 0, it implies that y has a value of 1, because 1 minus 1 equals 0. So y is going to be equal to 1. So from the first equation, I'm getting x to be equal to 0 and y to be equal to 0. This is not a critical point. Let me read what it is that I have in red. You're going to always factorize, and you're going to be resisting the temptation of canceling the x's or the y's. If we do that, we are going to be losing one of the values. And the value in this case that we'd lose would have been the x equals 0. So we're not canceling out. We're factorizing. Always get into the habit of factorizing. All right? So please also note that this is not a critical point, but a critical value. Critical value. So because we use equation 1 to find two critical values, x equals 0 and y equal 1, we cannot now use equation 1 again. We are forgetting about equation 1. The only other equation that can be used now is equation 2. So technically, we are solving. The rule is, when you're solving a pair of simultaneous equations, one of them is linear and the other one is quadratic, we do some substitution. All right? So I have two sets of values. Now, remember, x equals 0 is one of my critical values. I am substituting that into the second equation to find now the y coordinate in order for me to end up with my critical points. So why is the points? Because remember, equation 2 is quadratic, has a highest power of 2, therefore suggesting that I have two answers. Linear is 1. That's why I end up getting one answer for x, one answer for y. Quadratic, I'm expecting 2. So I'm expecting two answers for my x equals 0. So I'm going from my original equation. See here, my original equation is f of x by 3x squared y plus y cubed minus 3x dot. Bam, bam, bam. See here, this is it. Well, actually, my bad. We're not going for the original, because remember I did say that we're substituting into the quadratic. So it's not the original that I'm going for. I'm going for the quadratic. So this is the one I'm going for, because I'm trying to find my critical value. So I apologize for that. I'm trying to find my critical value. So it's not the original one that I'm going for. I'm going for this one. So this is 3x squared plus 3y squared minus 6y equals 0. That's my equation 2. Anywhere in equation 2, I see x, I am putting 0. See here, 3 times 0 squared plus 3y squared minus 6 times y. And that is equal to 0. 0 squared is 0, and 0 times 3 is 0. So I'm going to be left with 3y squared minus 6y equals 0. See here? So it is reduced here. Please do not do this. When you have your stuff, this line is the same as this line. Please do not say divide, set all of this equals to 0. So we're going to have 3y squared equals 6y, and then divide both sides by 3y. You're only going to be getting y equal 2. there's another set of value. There's another critical value that you're missing if you do that. Never, ever, ever cancel. Always factorize. So I am now factorizing. I'm looking to see what is common between 3y squared and 6y. And what is common is going to be 3y. What is going to be left is going to be, when I multiply, what do I multiply by 3y to give me 3y squared? It's going to be a y. What do I multiply by 3y to give me a negative 6y? It's going to be negative 2. So similarly to what I have here, I'm going to say here, so either this 3y is equals to 0, and of course, if 3y is equals to 0, it implies that y is equals to 0, or y minus 2 is equals to 0. Now, if y minus 2 is equals to 0, when I transpose and make y the subject, I'm going to add 2 to both sides. I'm going to get y equals 2. So now I have 2 values. But was I expecting those 2 values? Yes, I was expecting 2 values. I don't know what the values would have been, but I was expecting 2 values of y. How so, sir? Because equation 2 is quadratic. It's not linear, it was quadratic. Sir, what if equation 2 were cubic? What would have happened? Very good. Cube means how many? Question. Cube means how many?
2.
If quadratic is 2,
3.
3. So cubic is going to be 3. So if it was a cubic equation, it means I'd have 3 values. So the power in their polynomial gives you the order of the polynomial and tells you how many sets of answers you will get when you solve it at the 0 value. All right. So now, this y equals 0 and y equals 2 will be married to this x equals 0. So watch this. This is going to be x equals 0 when y equals 0. That's one critical point. And I'm going to go back for this x equals 0 when y equals 2. So both values in this set of critical points is going to be x equals 0. So the x equals 0 goes for both y's. Very important. So my critical points are going to be x equals 0 and y equals 0. I want you to note that if we had canceled, like show the cancellation here, we would have lost that critical value. We wouldn't have gotten x equals 0, y equals 0, because you see we don't have the y equals 0 here. And if we had canceled right here, so we wouldn't have had the x equals 0, we would have only had y equals 1. So now it is very important that we don't cancel, we factorize. And of course, the other value is going to be x equals 0 when y equals 2. So that's the other value. So we have 2 sets of values for y. Any questions? We did this last week and I'm just recapping. Any questions?
Repeat, sir. You said you had 3 answers for y. Repeat the last part.
We have 2 sets of values for y.
Repeat, sir.
We therefore have 2 sets of values for y.
All right.
Now, similarly, just as how we did x equals 0, we now need to look at our y equal 1. And of course, I can tell you, I have 1 y value. I'm expecting 2 x values. Why, sir? Because I'm again substituting it in equation 2, and equation 2 is quadratic. So I'm going to put y equal 1 into my quadratic equation. Anywhere into the equation 2 I see y, I'm going to put 1. So this is 3x squared plus 3 times 1 squared minus 6 times 1 equals 0. And I'm going to have 1 squared is 1, so 3 times 1 is 3, and negative 6 times 1 is negative 6 equals 0. My 3x I'm going to write back because there's nothing else to be added to it, and 3 minus 6 is going to be negative 3. So I'm going to have 3 x squared minus 3. Again, we're using the same principle of not canceling, but factorizing. Using the same principle of not canceling, but factorize. So I'm looking to see where my x equals 3. My x equals 3? No, I'm factoring out the 3. X is not equal to 3. I'm factoring out the 3. When I factor out the 3, I'm going to have x squared minus 1. I'm going to have x squared minus 1. Because what is really true is that either 3 equals 0. Can 3 be equal to 0? Class, can 3 be equal to 0?
No, sir.
No, so that value just don't that value just won't work out. What I'm going to do now, I'm going to let my x minus 1 equal 0. I'm going to let my x minus 1 equal 0. I'm going to let my x minus 1 equal
So
0.
question. So how did you get the 6 to disappear? I'm seeing that you have -3, but how do you get the 6? Not seeing it.
What is 3 minus 6, Daniel?
Oh, all right.
So recall the difference of squares. Recall the difference of squares. Recall the difference of squares. X squared minus 1 is the difference of squares. What I did right there is to show you, remind you how we did the difference of squares. X squared minus 1 is equivalent to x plus 1 times x minus 1. The difference of squares is going to be x plus 1 times x minus 1. X plus 1 times x minus 1. So if I look at the first bracket, what do I add to plus 1 to make it 0? It's going to be minus 1. See here? X equals minus 1. What do I add to minus 1 to make it to 0? It's going to be plus 1. See here? Plus 1. So it's going to be, when I set this equals to 0, I'm going to have either x equal 1 or x equal minus 1. So similarly to what we did up top, this is my y equals 1. Y equal 1 now has two x values, x equal 1 and x equal -1. So my critical points will be x equal 1 when y equal 1. The other critical point is going to be when x equal -1, y equals 1. So the y value will be the same, but I'm going to have two different x values. And up here, my x values were the same, and I had two different y values. So technically, I now end up with 4 critical points. 1, 2, 3, and 4. And those are the total critical points. Those are we have 4 critical points. Question?
All right, sir. I see that you have 0 for x. So for each x value, there are 2 y values, or that's not the case.
Yes, you're correct. For each x value, there are two y values, and for each y value, there are two x values.
All right, sir.
Will that always be the case? No. It just depends on what your first order partial derivatives come out to look like. When they come out to be two linear equations, boom, you just have one critical point. But once one of them come out to be a linear equation, I mean a quadratic equation, you will have multiple critical points. More calculation. I'm waiting on you guys to let me know where you have a difficulty. If you don't have a difficulty, let me know so I can move on.
I'm just trying to go through it to understand it because I wasn't in class last week when you did this part of it, so I'm trying to just go through it.
Okay, no problem. I'm trusting that the rest of you are also using this time to just look at it and then to ask me whatever question. I have the last part to do, and I'm gonna do it in another 3 to 5 minutes. I just want you to get an opportunity to look through, to ask me your questions, because I'm going to be doing one more like this in class. All right. Since there are no questions, to classify the critical points, we're going to be needing this general formula. To classify the critical points, we're going to be needing this general formula. And the general formula is going to be f of xx times f of yy minus f of xy all squared. F of xx times f of fyy minus f of xy all squared. That formula is going to be needed in order for you to classify your critical point. Sir, why do you have f of xx ab times f of yy ab minus f of xy ab all squared. That ab is just where the value for my critical point. We don't call it xy, we call it ab because those are my critical points. So remember, I have 4 critical points. I am looking at 0, 0 first. So we have to start with 0, 0 first? No. I just decided to look at 0, 0 first. So I have 4 critical points. I'm investigating my 0, 0 first. So f of xx times f of yy times f of xy all square. F of xx and f of yy so happens to be the same. Remember, we did a calculation up here. The second order partial derivative. My second order partial derivative gave me f of xx and f of yy to be the same thing. Then, sir, that can work? Yeah, man. Sir, will it always have the same thing? No. Each function operates differently. So just be very mindful and take your time to do the partial derivatives. Because one little mistake up top is going to be carried through for the whole question, and you're going to get the question wrong. You're going to get the question wrong. So you have to be mindful of that, eh? All right, now. Go back up here and so my 0, 0, of course, the first 0 in my parentheses refers to x, and the second 0 in the parentheses is going to represent my y. Since I have x comma y, it means that when I have 0 comma 0, the first 0 is going towards x, and the second 0 goes towards y.
All right, so one more question again. All right. So because you have 0, 0 and 0, 2, you have the 0 and the 2 for y because of the quadratic equation.
Say it again.
All right, so you have when x is equal to 0, and you plug in 0 in the quadratic quadratic equation, you would get 0 and 2 for the y values.
If you have, give me the example again. If you have what?
All right, if you have x equals 0 and you plug it in the quadratic equation, you have f subscript y xy equal the quadratic the equation, and you put 0 in it, and you get 0 and 2. That's how you get. That's how you got it.
Yeah.
Oh, okay.
So let me go and show you now. So when you look at the document, 0, 0, there is no x value, so we can't substitute an x here. There is no x at all. No x value at all. So we can only concentrate on the y. So see here, this is my f of xx that I'm looking at, This term here, the first one is my f of xx, and the second one is my f of yy. And of course, the one outside is going to be my f of xy. So there's no 0, there's no x in it. Hold on. All right. Answer the question, Daniel.
Sir, I understand now.
Okay, good. So 6 times 0 is 0. So I'm just going to have negative 6 there. See there? Still my f of x still is going to be negative 6. And I'm doing the f of y again. This is y. So I'm putting the 0 there. So I'm going to have negative 6 here. Oopsie daisy. My f of xy is 6x. So that goes to 0. That goes to 0. That goes to 0. So negative 6 times negative 6 is going to be positive 36. So I'm going to have positive 36. So D is positive. So we say that when D is positive and f of xx is positive, we have a relative minimum. But f of xx is not positive, it's a negative. So we're going to have a maximum. See here? We're going to end up with a maximum. Remember we say when D is positive, when D is positive, when D is positive, it is either a relative maximum or a relative minimum. When D is positive, it is either a relative maximum or a relative minimum. When D is positive, it's either a relative maximum or a relative minimum. How do we differentiate between the two? We have to look now at f of xx. If f of xx, the value of f of xx, when you substitute the critical points in it, works out to be a positive value, then you're going to have a relative minimum. But when you work it out and it becomes negative, you're going to have a relative maximum. So, or f of xx, or f of xx, when we look at it, see here, f of xx is a negative value when we substitute. So therefore, because it's negative, it's going to be a relative maximum. And that's why we got a relative maximum here. And then the other point is 0, 2. The same thing we are going to be doing. 0, 2. X is 0, y is 2. We have no x value for f of xx and f of yy. So what we're going to be substituting in now is 2, just like what Daniel asked. So my new y value now is going to be 2. So what I'm going to have, what I showed you here, is my f of xx 0, 2 times f of yy 0, 2. Because remember, I did say to you that my AB into the formula here are my critical values. My critical values. All right. So I'm just showing you here now how I put in the critical values. When y is equal to 2, what I'm going to have is 6 times 2 is 12, and 12 minus 6 is 6. That's why I get the 6 here. Similarly, 6 minus 2 is the same thing, so I'm supposed to get by the same 6. And because my x is still 0, like in the first one, I expect that my term out here is going to go to 0. So I'm just going to have 6 times 6 is 36. I'm going to have positive 36. Now, so I have positive 36 in this case. And positive 36 is I put greater than 0. So what is going to happen now is that I'm going to be required to look at my f of xx. What is my f of xx? Is my f of xx positive or is it negative this time? What's the value of my f of xx?
They're positive.
Mm-hmm. So because it's positive and d is positive, we're gonna have a relative minimum. We're gonna have a relative minimum. Why are we having a relative minimum? Because d is positive, positive 36. But sir, was it the first one 30 is positive 36 too? Yeah, man. Both of them work out to be positive 36. But why both of them are different? In the first instance, 0, 0, the value of f of xx is negative. See it up here, so negative 6. So because d is positive and f of xx is negative, then we have a relative maximum. When d is positive and f of xx is positive, we have a relative minimum. So because it is positive down here, we're going to have a relative minimum. So that's why we have a relative minimum there. So those are 2 points. Then we did 0, 2, we did 0, 0. Then we have 1, 1 and negative 1, 1. Which one did I do first? I did 1, 1. So let us look at our 1, 1. Anywhere in the function, I see y, I put 1. When I see x, I put 1. There is no x, but there's a y. So 6 times 1 is 6, and 6 minus 6 is 0. Uh-oh. That means both of them will be 0 and times 0, sir. Yes, I. But in this here case, no, I'm going to have 6x all squared. So this is going to be 6 times 1 is 6, and 6 times 6 is 36. I'm going to have this 36 here. So all of this minus my 36. Uh-oh. When I do that calculation, I'm going to have a negative 36. Wow. The mere fact that d is negative, I don't have to check f of xx. Once d is negative, I have a saddle point. Once d is negative, I have a saddle point. Once d is negative, I have a saddle point. I don't need anything more. Once d is negative, saddle point. Once d is negative, saddle point. Any questions?
No.
All right. Now we need to look at f of 1, 1. We need to look at f of 1, 1.
Sir,
Mm-hmm.
I was just about to ask. You have 0, 0 minus 36. Can you go back through that?
Remember the value of y is 1. So 6 times 1 is, we're interchanging the y for 1. So 6 times 1 is 6. And 6 minus 6 is 0. You see that?
Yes, seeing that. And how you got so you got 6 and you square it and you got 36.
Right.
All right.
Because it is xy all squared.
You're understanding.
Good. And then 1, 1 now is going to be, sorry, negative 1, 1. Negative 1, 1 is going to be when this here, when I don't have an x value for my x and my y, it's just a y value that is still 1. Of course, from up top, it's still going to be 0 times 0. But my x value now is going to be negative 6 all squares, which is going to give me a positive 6. So I'm still going to end up now with a minus a positive 36, which is a minus 36. So d again is less than 0. So we have 2 saddle points. So for that question, I end up with 2 saddle points, one relative maximum and a relative minimum. And then what I had done up for you is this one question for do now, that I'm still going to give you an opportunity now to do it for me. Start now for me, please. As you go through and you're still in a challenge, verbalize it so that we can just work through it, get the issue out of the way quickly. All right, thank you. Are you guys working?
Yes, sir.
All right, good job. Always stay, always stay.
So I'm stuck. Um, I'm stuck at when you should find the critical values. That's where I'm stuck.
All right, where the rest of you reach? Talk to me now. I need to know whether or not I should start working the question or sharing the question. Where the rest of you are?
So you can share the question.
Yeah, so I just worked out the first part. Now getting the critical part, the second part of the let's see.
All right. Mm, all right. Let me go ahead and share now. What was the question again? Oh, come on. I don't believe I'm making something to me. Jesus. All right, the system shut down on me. By the way, are you hearing me? Oh yeah, you're hearing me. The system shut down on me. Let me do the question from my head. Can I write it from here? I don't have enough space to write. Oh yeah, I will have enough space to write. I can write it from here because computer just shut down on me. All right. Oh, come on. Are you seeing my screen? Are you seeing my screen, guys? Is anybody there? You see my screen?
So, see,
Are you agreeing with that? What I have there?
Hold on. Through Excel.
yes, sir, I agree with it.
Yeah.
So that's the point where I got stuck up.
All right. So all right. So now we're at the point where we're going to set f of xy to equals 0 and fy of xy also to be equals to 0 um, by solving simultaneously. So I'm going to let 2x plus y equals 0 and x plus 2y plus 1 equals 0, which implies x plus 2y is equal to -1. Do you agree? Can you see? Do you agree?
Yes, sir.
So what I now have, my simultaneous equations are now 2x plus y equals 0 and x plus 2y is equal to -1. Can you solve that simultaneously for me, please? I want to get you actively involved in it now. So Daniel, you see, it wasn't much further for you to get to that point. So what I want you to do for me now, Papa, and the rest of you, is to solve that pair of simultaneous equation for me. I'm going to give you 3 minutes to solve the pair of simultaneous equations for me, and then I'll come and work it. That's okay?
All right, sir.
Okay.
I got y equal negative a half.
Coming down here.
Wait, sir.
Nancy, I'm coming. Give me 1 second.
Okay.
Okay. So. Finish it, Daniel?
Yes, yes, sir.
What about the rest of you?
Give me a moment, sir.
Waiting on you, Arthur. Can you say Arthur?
Semi-finishing.
You don't look at the screen. You just go and work, and then I'll go on. And I'll go and look at.
Well, for when you put the let's see, -1 x plus 2y -1. Then the subtract. Okay.
So.
-1 get to the first one. I'm gonna put equation the first equation by the second.
Okay. All right. So what I am going to do is, all right, I'm going to solve my semantic.
-1.
what I'm going to do here, I'm going to multiply equation 2 by -2 so that I can eliminate the x's. So I'm going to have -2x minus 2y is equal to +2. Call that my equation 3. Then now I'm going to add in equation 1 and 3. So 2x minus 2x is 0, and y minus 2y is going to be negative. It's going to be -2y, negative y. And then 0 plus 2 is going to be equals to 2. Divide both sides by -1. It implies that y is equal to -2. Anybody got y to be -2? No.
So I see where I did the error. So
You sure as you made the error or me made the error?
repeat that, sir.
You sure as you you made the error or me made the error? Hold on, let me just check something here.
-2 over 3 for y.
Let me just check something here.
-2/3. Mark, why?
You get -2/3?
Yeah, for y.
Yeah, for y. It's supposed to be -2/3. I just checked it a while ago. I didn't do something here. It's supposed to be -2/3.
Okay.
Very good, Ottilie. I'm checking to see where I went wrong. -2x minus -2 times +2 is 4, don't?
4, yeah.
Yeah, so it's not 2. It's supposed to be 4 right here. So
Okay.
it's supposed to be 4. So -4y, and then no, y minus 4y is -3y. And then divide both sides by -3. It's going to be equals to -2/3.
2/3.
Very good, Ottilie. I'm proud of you. -2/3. So that's the value of my y. Y is -2/3. Let me ask you now. Can you go and find the value of x for me, please?
Yeah.
Find the value of x for me, please.
Yes.
Should be 4x plus 2y minus x plus 2y equals that is 0 minus negative and negative positive 3x plus 1/3. Substitute 4x plus 2y minus x plus 2y equal to 0. Minus x from 4. X from 4x give it 3x. And 2y minus.
Ottilie, your mic.
Oh, sorry.
That's it.
Then anyway, once I get back to them, I'm stepping away. I got 1/3.
I'm right here, mommy.
Well, I'll soon be back, sir. Just a minute. For some what?
Very good. Well, your 1/3 is correct. Very good. What is what, Daniel?
So I got two, 3 or
Negative 2/3.
6. Yeah,
You know what you got?
-2/6.
You got 2/6.
Right. -2/6.
It's supposed to be positive 2/6. Check it for me, please.
Yes, sir. I still get the same answer.
All right, I'm working it now. So you get the same thing. Which equation you put it in, Daniel?
Equation 2.
All right, I'll put it in 2 so that you can see your error. So x is equal to 1/3. Look at what I did. Look at what I did in order to get my 1/3.
Yes, sir. I seen it.
You see now? Next up, next up, who? How many was here? Okay. All right. So you see, I was saying to you, but once you have two linear equations, you get only one critical point. So my critical point is going to be 1/3, comma, -2/3. Try and classify that for me now, Daniel, and the rest of you. Try and classify it for me, please. F of x times f of y minus f of xy all squared. Start, please. Start, please. I have one more to give in class tonight, you know.
So was it f of x y squared?
What? What do you mean by that?
As a part of the equation formula for the classification.
F of x times f of y minus f of xy all squared.
Okay.
I wrote it in green on the screen. It's on the screen, actually. question. Almost finished. This is just the last part of the question. Okay, you back there?
I got 3 for my answer, sir.
You got 3. Okay,
Yes.
3 is correct. What's the classification?
It would be minimum.
How you know?
Because it's a positive value. D is a positive value.
And? And? And what?
What else, sir? No, no.
You have to look at your f of x value. Is f of x positive or negative?
Positive.
Mm-hmm. So because d is positive and f of x is positive, you'll have a relative minimum.
When both are positive.
Yes, sir.
Oh, okay.
All right. No. So d is going to be equal to f of x, which is f of x is that, f of y is that, f of xy is this. So d is going to be f of x, which is 2, times f of y, which is 2, minus f of xy. F of xy is negative, is positive 1, all square. 2 times 2 is 4. 1 squared is 1 minus 1. It's going to be equal to 3. So since d is greater than 0, I mean that is positive, and f of xy is also greater than 0, comma, then we have a relative minimum. Very good. We have a relative minimum. Next, a wake up. Are you okay? Talk to me now.
Sir, to move on from here, I want to know how to get to the next critical point.
There's no other critical point. That has only one critical point.
So the question is finished then.
Yes, I.
Okay, sir.
So I'm actually trying to sign back into the other device so I can share the other questions so you can go ahead and do the 6 calculations, the f of x, 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 y, 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 x, y, and y, x, and then you solve the simultaneous equations, and then we take it from there. This is a past paper. And it's too much to write the question here. So I'm going to share it on another screen. So let me stop share here. Stop sharing. All right, I'm sharing the screen now. Um, that's the past paper question. Past paper Wednesday, 2019, May 15. That's the question. A small startup company produces speakers and subwoofers for computers they sell through our website. After extensive research, the company has developed a profit function in thousands of dollars. Find a production level that minimize profit. So you have your multivariable function. Go right ahead and do the 6 calculations for me first, and I'll help you to navigate through this one. Start for me, please.
Sir,
Mm-hmm.
I'm thinking that pi is just a symbol to
And you're
replace
correct.
it.
Just like we have f of x by, I have pi of x by. So just use that as pi. Pi is just a symbol. Just like what you named Daniel? Yeah.
Okay, sir.
All right. What I just did a while ago is to share the document with you that we just worked on.
In WhatsApp, sir?
In WhatsApp, yeah. I want all of it to be working. I don't want you guys to sit down there and you have to get to practice with this question. So I really want you to work so I can know where it is that you have your difficulties. Please. Are you guys okay?
All right, so I have a problem with simultaneous equation.
Yeah, I know that's a problem, you know. Give me a minute, please. We have to get the simultaneous equation saga out of the way. Can't let it conquer us, or else we're not going to get the full marks of this question. Ottilie, are you back? Nesta? Nesta,
So
go
I
to
just
sleep.
came back. I'm not getting on the question.
Okay.
Mm-hmm.
So Daniel, you finished with the 6 differentiations?
So I only have the first differentiation. Can't determine the critical points.
What do you mean your first differentiation? You want to have pi by x and pi by y?
Yes, I have that.
Yeah, so why don't do pi x and pi y and pi x and pi y x? Do those for me, please.
Okay.
Get into the habit of doing all 6 of them up front, because you get about 5 marks or 6 marks for those. So if you're stuck, at least you know you get those 6 marks out of the way.
Okay, sir.
Mm-hmm.
All right, step it down for 2 seconds. I'll soon come back. All right, finish it now, Dan.
As it relates to
Yes,
differentiation.
please.
You finish the 6 calculations, Dan?
Yes, sir.
Utterly, how you say?
Repeat.
I was asking Utterly, you should finish those also. Look at that, Dan, and tell me if you agree with what I have.
Or you get 2x for pi y.
Well, you get 2x for y. I'm differentiating pi by y again. So the x squared will go to 0, and the negative 22x will go to 0 because there's no y in it. And the 2x is a constant here. This 2x is a constant, so I write it back here. So, and when I differentiate y, I get 1. So 1 times 2x is just 2x.
Besides that, sir, I agree.
You agree?
Yes.
I'll tell you how you say it. All right, solve this, solve. All right, so x, pi by x and pi by y, the ones that I have in blue, are what will be used to solve the simultaneous equation. Let me give you a start. This one is difficult. It's 30 marks. That one is 30 marks. You're going to solve it by substitution. I'm not training all of it. I'm just going to help you out a little bit and then let you do the rest. And that's my help out. So I'm putting my pi by x and my pi by y to be equal to 0. As you can see up top here. Are you following me?
Following.
All right. And then I'm going to have my 2xy minus 22y plus y squared equals 0. I'm transposing equation 1. I'm transposing equation 1. Both equations are quadratic. You can see the highest power in it is raised to 2. That means I'm going to have more than one set of answers. I should have about 2 answers. So I'm transposing equation 1. So what I'm saying is 2xy is equals to, I'm adding 22y to both sides. So over this side it becomes positive 22y minus y squared. Can you agree with this line? Look at me if you agree with that line.
Agree.
And then now, I want to make x a subject. Well, matter of fact, I can only make x a subject here. All right? So I'm going to make x a subject. That means I'm going to divide both sides by 2y because I want x alone to be on one side. So I'm going to divide here by 2y and all of here by 2y. So this is why I have the 2y down here and the 2y here. Right? Please note that cancellation was not possible before factoring the y's. I have to factor the y's first. So look at what I'm doing. I'm looking at my numerator to see what is common. and I recognize I can factor out a y in the numerator. So I factor out the y, I'm going to be left with 22 minus y. 22 minus y. So how do you know? Because y times 22 is 22y. Y times negative y is negative y squared. And all of that is divided by 2y. My y's are then able to cancel out. Of course, you know I can cancel out the y from here. So the 2 from here, so I'll just leave x on this side. So I have the x on this side, and then I'm going to have 22 minus y over 2, which is this equation. Look at this calculation again. Tell me what it is that you see, because the second part of the question, I'm going to ask you to do that for me with the substitution. Let me know if you see that part.
Oh, sorry, pass the first partial and the second partial derivative already.
Yeah. Yeah.
Okay.
We don't have much time. I wanted to see how well you do this one. I sent something in the WhatsApp group for the homework question that I had on the thing. So you should have that homework question. And then I'll send out the solution to this one after class. Nestor, Nestor's on sleep, you know.
Yes, sir.
You wake up?
Yes, sir.
All right, never mind. Obviously,
Sure, stress out. So yeah, y equal to 0. So just work it down.
no,
Yeah,
I was working it, you know. I was working it. I mean, I did
0 and then x are gonna be 22/3 and 0. No, no. I get it.
All right, so you see, the answer that I got when I trying to simultaneous equation, that is 2y squared equals 0. So I put
Yeah.
x,
For y,
yeah, so if I
yeah, I'm
put
gonna get
x,
0.
I put x into equation 1,
waiting.
2y squared equals 0. And I don't know where to go from here.
When you put it in which one of the equation now? I'm gonna put in y equal to 0 in a second equation. I may get 22 minus 2x. So I'm gonna try substitute y in a second equation. I'm sure I get.
I did say to that. I did say to you that you're going to substitute. X. Okay. All right. All right. Do you understand up to this point where we made x the subject of the formula to get 22 minus y over 2?
Minus y over 2, yeah.
All right. Let me just pause and say something to you here. Is it what we're doing here now has nothing to do with calculus 2, if I were to be honest with you.
Simultaneous equation.
Thank you, please. You know where calculus 2 ends in this question? When we did the 6 partial derivatives up top. You see, the moment we say we're going to solve simultaneously, that is not calculus 2. That is not calculus 2. That is CXC math. I mean, very frank and honest with you. I'm not trying to belittle you. I'm just telling you straight up. So I don't want anybody to leave calculus 2 hard, because that is not calculus 2. That is CXC maths that we're doing here now. So since we established that, I'm going to go back to calculus 2. So we finish part of calculus 2 up top. Then we're talking about simultaneous, which is CXC. And then after we finish the CXC and get our answer, we're going to go back to the calculus 2. So let me help you work through the CXC stuff, students. I promise you that if your simultaneous equations are not where it's supposed to be, you are going to be in problems, because you will get a pair of simultaneous equations to work out in this question. No two ways about it. Real talk. And I did say to you, I'm going to get the big boys out of the way first. So that's why I'm doing this topic now, because this topic, mark the question won't come for 30 marks like this one. The question will be 20 marks, so it will be a little easier than this one. So if I were to admit, yes, this question is a little on the rough side. But I don't know. CXC can, almost CXC, CCCJ can very well say, let us care about this question because it's 2019 we carried it. You see what I say? So it's best for me to go to the question and you try to understand it, so that if the question comes back, you know exactly what to do, so you can pick up a full marks. That's all I'm saying, so that you can pick up your full marks. All right?
Yeah.
So you agree with me that x is 22 minus y over 2. And this is what I'm going to substitute into the...
22. Hold on, sir. X you said is equal. Yeah. So far.
All right.
Divided by 2. Yeah.
So note, this must now be substituted into the other equation. Must now be substituted into the other equation. What's the other equation? I use equation 1.
2x.
It must now be substituted in equation 2. All right? So look at what I'm doing. So I'm recalling what equation 2 is. This is what equation 2 is. So anywhere in equation 2, I see x, I'm putting 22 minus y
22
over 2.
minus y. 2.
Yeah. Anywhere in it, see, I go put that. No, me I go tell you, this part of the CXC something is plenty, but don't worry about it. It can be solved. Let's go.
Ooh.
X squared. So it's 22 minus y over 2 all squared. See it here, so?
Not squared.
Minus 22. I just put it as 22 over 1. Same 22. And say x here, 22
22
minus y.
minus x over 2.
And the reason I put this over 1 is because the x value is a fraction. If the x value was a fraction, I'd just leave it as it is. Me divided by 1 won't change the value from being 22 or negative 22. Plus 2, see here, plus 2, and again I put it over 1.
X equal to 22.
Is very good. 22 minus y over 2 times this y. That y is this y here equals 0. I want you to note. I want you to note that this. I missed out something? No, hold on. Okay, what I want you to note is,
400.
yeah, but what I want you to note is this. What I want you to note. 22 minus y all squared over 22 minus y over 2 all squared is the same thing as 22 minus y all squared divided by 2 all squared. So when I have everything here all squared, it means that is the numerator that is being squared as well as the denominator. So 22 minus y over 2 all squared is the same thing as 22 minus y all squared over 2 all squared. Fair enough?
Yes, following. Yes, sir.
All right. And then now, I'm trying to fix up this part here. 22 minus y all squared is the same thing as 22 minus y times 22 minus y. Can you see that? That's what 22 minus y all squared is done. 22 minus y times 22 minus y. Talk truth. Hello?
Yes, sir.
22 minus y all squared is the same thing as 22 minus y times 22 minus y.
Sorry, repeat the question. I didn't hear it properly.
I'm saying 22 minus y all squared. Is it the same thing as 22 minus y times 22 minus y?
Yes, sir.
Yeah, man. And 2 squared
Yeah,
is the
it's
same.
just writing it out. Yeah.
Very good. Very good. Now watch me now. 22 times 22 is 484.
Oh, 484, man. Okay.
22
22
times y is negative 22y. Negative y times 22 is another negative 22y. And negative y times negative y is a positive y square.
Positive y square. And then 2 times 4.
And 2 times 2 equal?
4.
4. I have only one whole number, 484. I write it back.
Put like terms together.
Very good. That's exactly what I'm doing. Very nice. And negative 22y minus 22y is going to be negative 44y. And I have only one y squared. I put it back all over 4. So what I now have is all of this piece here is now 484 minus 44 plus y squared over 4. So I just put it back right here. So, and watch me now. 2 times 1 is 2, and 2 into 22 goes 11. So this is minus 11. See here, minus 11 times the 22 minus y. See it right here, so? So this term reduced to this. Watch this one here now. 2 times 1 is 2. 2 divided by 2 is 1. 1 times y is y. So it's going to be 22 minus y times y. See here? 22 minus y times y equals 0.
Then y.
Then I am multiplying through by 4. Why, sir? Because I have a denominator here as 4. Yeah. So if this was 10, I would have multiplied through by 10. If this was 7, I multiply through by 7 because I want to get rid of this denominator here. So watch me now. When I multiply 2 by 4, magically, because we have a 4 here, those two 4s cancel. So I'm just going to have the numerator alone. You see that? All right. And then 4 times negative 11. Well, sorry. I just going to put 4 times all of this.
Everything in there, so.
Yeah. And then now, this negative 4 is the same thing. We're just trying to work out what is inside the parentheses first. 11 times 22 is 242. 11 times minus y is in negative 11y. And of course, plus this 4 times 22 times y is 22y. And negative y times y is negative y squared. Again, pause right there. I know this is a lot of heavy.
Sir, hold on. Let me see, right? Alright, so when the second part we work out, I say I multiply by 4, we get the first part, the last part, no. Where I got to oh, you're working there's the first. Okay,
right.
so
this y times 22
y.
Very good.
And then y
times
squared.
Negative y squared.
Yeah.
Very good. So you catch up now?
Yeah.
All right, so watch me now. Very nice. Watch me now. All of this, I write it back. Negative 4 times 242 is negative 968. Negative 4 times and negative 11y is positive 44y. 4 times 22y is 88y.
Okay.
And 4 times negative y squared is minus 4y squared equals 0. So you see, I'm reducing that stuff every time.
Yeah.
But look here now. The negative 44y cancel this positive 44y.
Yeah.
So I'm going to take it out.
Okay,
and I put the last terms together. So we have 484 minus 968. Then 88y minus 4y squared plus this y squared. You see it?
Yeah.
Parentheses must be the same in order to factorize. All right? Watch me now. Watch me now.
It was something for that now.
Watch me now. What is 484? What is 484 minus 968? Minus 484, don't.
968. Minus 484. 2 times.
484.
You left with 484.
Again, no, then negative 484.
Negative. Yeah.
Yeah.
Okay. So negative 484.
So you're going to post this class recording?
Yeah, man. As I have been doing. All right. So watch me now. So this negative 484 minus 968 is negative 484. The 88y is a standalone, so I put it back. But negative 4y squared plus y squared is negative 3y squared, don't?
Hold on. Negative 4y squared is a minus r plus you have there.
Negative.
Negative 1. Oh, negative 10. Okay. So it will be 3. I got it.
We have negative 3y squared, don't?
So, all right. So negative 4y squared plus. Oh, yes, sir. No mistake. Yes.
All
negative.
Right. So
negative 4.
Look at what I'm going to do right here. I'm going to
Care about the 0?
No, I'm just going to multiply through by -1.
Okay.
Why?
Two by one. Just by -1.
By -1, yes, yes, I'm just trying to.
Negative times negative or positive. Instead of a negative.
So what I'm going to have now, is a positive 3y squared, a negative 88, and a positive. Can you agree with that? When I multiply through by -1, two negative numbers, a positive number, this becomes negative, and this one becomes
and that
positive.
becomes positive.
All right.
Very
good. So I'm rearranging now. To give me agree with that?
Rearrange it to give you 3. Okay. So put the y, so y squared, then I put the y value, then I put the constant.
You agree with that?
Multiply through. I got break it down. Hold on. So 3y minus 22. 22
So
times
we're going to factorize this now to get this.
Yeah.
All right. So I'm going to multiply 3.
Yes, sir. I agree.
Yeah, I'm going to multiply 3 by 3 by 484.
Same other thing to do this.
Yeah, man, I'll say that for the man.
So 3y, like your factor, like you have 3y minus 22, and then you don't have y. But probably sit down and stop. Say, oh, no, how much I work this now? Because it's just like doing like when you're doing the difference between two squares, but this one now you don't have the plus and the minus value. But for what you did right here, so now more thing to do this, sir. Like how you do it. See why because you gonna have 22 times negative 22 times negative 22 there. So no factor that. Yeah. But yeah. That's so hard if you think it through for do it proper, the right way.
All right, no problem.
So get to the point where you said either y 3y minus 22.
What is that? Say it again. Start off again. What did you say?
I'm asking how you get to that point.
Okay, that's what I'm doing. Ultimately, was speaking, so I allowed her to finish speaking. So what we're doing here, this is factorization. I'm going to be multiplying the coefficient of y squared by the constant. Multiply the coefficient, COEFFICIE, of y squared by the constant. All right. So in doing that, I'm going to get 1,452. 1,452. So I need to find factors of 1,452. When multiplied together, will give me 1,452, but when added will give me 88. 11 times 3 is 33. 33 times 2 is 66. And 11 times 2 is 22. So that's 88. So the factors are 66 and 22. Factors will be 66 and 22. So what I may have is minus 66 so I'm going to have 3y squared minus 66 minus 22 because when I multiply negative 66 by negative 22, I'm going to get 1,452, which is what I will get when I multiply 3 by 484. This is factorization by grouping, you know.
Sir,
Yes, sir.
the kind of factorization is different from the one I used to, because in the case you have 3 in front of the y square.
Okay, so when you have what is different if you have 3 in front of the y square? Tell me how you get it to be different.
Usually you would have 1 front of
No man,
y square.
no man. If you have a number that is greater than 1, you have to multiply this number by the constant, which is this. So when I multiply 3 by 484, I'm going to get 1,452. So when I multiply the coefficient of y squared by the constant, I'm going to get 1,452. So I'm going to factorize the 1,452, and this is what I get as my factor, 66 and 22.
And the sum would get the middle term.
And then the sum up very good. So it's the same thing that you remember, but it don't always have to be a 1 in front of the coefficient of the square term. It can be any number. All right? And then now when I find my factors, then I'm going to group. That's what I get in a group. See, I put these 2 first terms in it, boom. I'm factoring a minus sign, so this sign has to change to a negative sign. And when I factor out that now, I'm going to get 3y is common. Three y is common, so I'm taking out 3y from both. And then I'm going to have 22 there. And 22 is common. And again, have 22 here. So when I factorize, I recognize here that 3y is common in this bracket. So I took out the 3y. What do I multiply by 3y to give me 3y squared is a y. And I'm taking out 3y from here, so I'm going to have 22 left. Because 3y times 22, negative 22 is going to be negative 66y. What is common here, that is common there, will be 22. What is left will be y minus 22.
All right. And then now, since y minus 22 is common, I'm going to have that. I'm going to have 3y minus 22 equals 0. And then this is now how I end up getting now. Either 3y minus 22 is equal to 0, or this y minus 22 equals 0. So therefore, y in this case is going to be 22 over 3, and y in this case is going to be equal to positive 22. I'm going to stop right there, because the other part of the question now is you have to go substitute to get all of those values, and then do this part here, right? I'm gonna send this off to you now, but do me a favor. I don't expect you to do anything more tonight. Thanks for coming out. What I'm gonna do is send it off to you now, and then I'm gonna ask that you, let me just save it. I'm gonna ask that you bright and early tomorrow morning, God sparing life, you're gonna go through this question for me. The question can come back. It's a past paper question. It's a past paper question. I'm gonna ask that you do this for me, please. And you worky, and then you send it off. You send off your questions that you possibly have, so that we can deal with them. Students, this is a must-have. This is a must-have. It is going to come.
I gotta work it on different. I gotta work it after me get the same answer.
It's a must-have. It's going to come. That much I know. What I don't want you to do is not prepare for it, and then you lose those 20 marks. The marks are so much easier for you to get. I mean, you know, you can get it. You can pick up those marks quick and fast, easily. So I'm going to ask you to just work with me. Do what you need to do. And the document is being prepared. So I can send off. Are there any questions before we end the session? Any questions of me?
Not yet. No, sir. No, not today.
All right.
Sir, the recording for the previous class, is it on the channel?
Yes, sir.
Okay.
All the records are here.
Okay, sir.
All right. So I'm uploading the document, so you can sign out until we meet again. But please, guys, don't wait until Friday before you take up the calculus 2 again. Time is running. I need to finish off this thing so I can give you a mid-semester on it. This is one of the questions that I want to give you mid-semester on, right? Among other things. So please, the document is now in your WhatsApp. Use it and use it well. As soon as the recording comes for this class, I'll send it off. Pretty much that's it for the night. Have a good night.
See you later, sir.
When is mid-semester, sir?
Because there's something here. All right, maybe not Friday coming. I give you enough time to digest it, but give you the mid semester on maybe like all the 4th.
No problem.
Hmm?
No problem. And the topics that we covered so far.
Absolutely. Everything we covered so far.
All right.
Cool.